Hello YouTube, I think we have a good video for you tonight. Electrical crimps, splices, PIDG crimps we're going to deal with tonight, made with this type of tool. Reason for this video, all of us oily guys who work on aircraft engines and airframes will have been at some point chastised by the fairies, the avionics guys, the sparkies, for not having our crimping tools calibrated and using the correct tool for the job and expensive approved crimps, and they have got a point. Now firstly, you got to have the right tool for the right crimp, and that is a subject for a whole nother video in itself because there are hundreds. Tonight we're going to deal with these PIDG crimps, yellow or red. In this case tonight we're just going to be using the red PIDG crimps, and the tool number that we have got is correct for those crimps. So that's going to be our gold standard calibrated approved crimps. We're going to compare them to some other Farmyard crimps and spade connectors and bits and pieces. Keep watching to the end because we test them to destruction with current. It's kind of fun. Alright, so we're just going to do this type of PIDG butt splice here, and first thing I'm going to do is set the tool to squeeze the insulation barrel that grips the insulation part of the wire to a suitable pressure for this wire thickness. So I'm just going to put the unstripped wire into the insulation squeezing or retaining part of the crimp, alright, like that. Then I'm going to squeeze it. I'm going to take it out. I'm going to just gently bend the wire with a light tension on it, and it doesn't pull out, but if I pull it a bit harder, hopefully it will pull out. And we can see that the insulation barrel, or the insulation supporting that crimp, has formed a nice diamond shape, and although it gripped the insulation reasonably firmly and supported it, it hasn't cut into it. So that, with these pins in position 2, is about the right setting for the insulation side of the crimping tool, or the, I don't know what you would call it, but this half of the die. The other side, okay, that's made a nice diamond shape there, and it supported the insulation of the wire. It didn't cut into it. This side of the tool crimps the conductive part of the crimp onto the stripped part of the wire, which is down here, and that is set when the tool is made, and it's checked with a go no go gauge when the tool is calibrated. And some of the tools imprint little ribs or dots onto there so that you can see if the crimp is formed correctly and the correct tool has been used. But like I said, we're not going to get into that. There are so many tools and so many crimps. We're just going to concentrate on one type for this video, and that's this type of PIDG. Alright, so these are not cheap, and they are an approved crimp. You'll all have heard of AMP, Aircraft and Marine Products. These are cheap, nasty things like you get from DIY stores. And you can see straight away they don't have the insulation barrel in metal. These do. These I was always told we don't use on aircraft, but I know of several major manufacturers of certified aircraft who do use them. But let's just, for a start, put one of these PIDG crimps approved. These are, as I say, AMP. I think they're TE connectivity now. They are made to a spec. They have a mil spec and you know, an approval, and they are generally used in aircraft wiring looms. Usually only one splice per wire segment, staggered if you have to put any number in a bundle, and they seem to give pretty good service, and we'll have a look at the reason why and just compare them to the rubbish ones. I think it'd be fun to test a few to destruction with both current and tension and fatigue. So that's what we'll do. We'll put this in the crimper correctly. Just snug up the jaws just against the crimp there. There's a ratchet that won't release until it's fully crimped with this type of tool. Now we've stripped the wire to the proper length with the proper tool, we haven't nicked any strands. Put it in like that. There's an inspection window in the centre of this crimp so we can see we've got enough wire in. And just as a bozo check, I just sometimes make sure I've stripped it right. Use my fingernail as a guide and make sure that the stripped part of the wire is going to end up in the conductive part of the crimp, and the unstripped part of the wire is going to end up in the insulation supporting part of the crimp. Other than that, put it in, close the pliers all the way until the ratchet releases, take it out, and that should be a good one. Right, I think it's going to be kind of fun to compare these to the cheapies and the stuff that we shouldn't be using and test them to destruction with current. Might be fun. Let's burn them out. Right, slightly different type of crimp. This is a knife disconnect. I'll just show you this because you can see it a bit better. This tool has a wire stop inside it. Now if I push the wire in, see with the butt splice you use the inspection window and the wire stop just locates in the inspection window dimple. With this tool the wire stop kind of holds the crimp in position and it will just keep the wire. If you strip the right length of wire and you push the wire up to the stop, that will give you a good location of the wire in the crimp if you're working in awkward position and you can't see what you're doing. So hopefully you can see there. Then I've formed the crimp. That insulation is supported. That's worked. The conductive part of the crimp has squeezed all the strands very tightly, and you can just see a little bit of wire sticking through there, which is where the wire stop on the tool located it. This should be a good one. As I say, we'll test some of these to destruction and see how we go. Alright, for those of us who grew up on farms, this is how we will have been taught to do crimps. Take an old blunt pair of side cutters and do your best to strip the wire, cutting some strands as you go. Yeah. Another stab at that, give it a twist or two. Yeah. Come on. Where's the lens on this camera? It's all gone blank. Right, there you go. Focus, you. Come on. Here we go. I haven't quite got all the insulation off yet. Give another stab at it. Just yep. Come on. Yep. All right, we're done. Take the old doobly-doo and shove it in as far as it'll go and give it a twist. Now there is some kind of wire stop inside this cheap crimp. But there's no inspection window type thing, but there is some kind of wire stop, so let's try the old farmyard method. Getting a pair of pliers and flattening out as much as we can. Look at that. Yeah, that's proper. We're going to test this. This is our baseline standard. Alright, it's time for science. Cheap Aldi vodka, a stopwatch, a drill. We're going to see if we can do a fatigue test on our farmyard crimp here and concentrate thousands of hours of service into a few seconds on the stopwatch here. I'm going to try and kind of I've got a feeling the wire strands are going to fatigue on this cheap crimp because the insulation is not supported and there's no kind of strain relief on it. But well, this is the best test I could devise. And the more vodka I drink, the better the commentary gets. So let's give it a go. That wasn't quite what I had in mind. I think we're going to have another stab at this one, but you can see it's not a pretty crimp. I'm going to make up another farmer's crimp, a cheap crimp, but with the proper stripping and a bit better. Give it a fair go. once more. Oh, we're doing better this time. Ah, okay. Still failed in about 15 seconds without wrapping. Alright, this is more like what I intended it to be. 3, 2, 1. Alright, even when it did wrap up, it hasn't really done. That crimp is still sound, and the Farmyard one failed in a few revolutions and a little twist. So that's pretty good proof of the fact that the insulation support in these crimps is pretty important. Alright, now let's see if we can't get the proper crimp tested to destruction. Nope, and another go. It's getting warm. Must be doing something. Yeah, I think when the wire warms up, it gets kind of soft. We may be at this a long time before we destroy this one. I'm gonna give up on that. Good. Amazing what that little bit of support there will do to reduce the fatigue in the wire. Right, it's current testing time, and first thing is I'm surprised how much current we had to put into these to make them hot. Now I've got nearly 45-50 amps flowing in this wire, and the crimp is not hot. Alright, now you may be surprised to see what happens here, because the crimp is not hot. The wire certainly is, and here we go. The insulation's come off there and it's glowing red, and the crimp is really intact. You can just see there the conductive part of the crimp is beginning to swell its insulation, but it has not done badly at all. Right, crimp the second. This is the spade terminal. Not the cheapest quality, but actually the right hand side is a cheap one. And again, it took 30 or 40 seconds at over 40 amps for this to start to get hot. Really, I'm feeling the wire hot before the crimp's hot. But in this case, and I'll slow the video down in a minute when it starts to go, I think both the wire and the push on, the fast on part of the crimp went at the same time. Right, just going to slow this down a bit now. Right, we're slowed down, and I think, right, if you look at the right hand, the cheapy B&Q crimp, I think, apart from a bit of a heat from the push on, the spade part, which you'd expect, I mean, bearing in mind the wire is now red hot, is doing pretty well. But I think if you compare right to left here, the right hand side, yeah, it's swelling up in the part of the crimp that grips the wire. It's generating some heat there, and it's about to blow there. It's kind of swelled up and smoked on the crimp. So not quite as good as the other one. Right, so lastly it's the Farmyard crimp. Here we go. Still think the wire's going to go first. Right, I think I see smoke from the ends of that crimp. Now the wire, we've slowed down here, the wire has gone, but I think the crimp went, oh, it probably generated some heat in there because of resistance. There's smoke coming out the crimp as well as the wire. I'm going to say that the crimp in this case did not exceed the rating of the wire. Right, if you'd exposed this to a slightly lower current for a longer time, I think that crimp would have failed before the wire. And that's not a pass. Sorry, Farmyard crimp. Right, it is mechanical testing time. Not sophisticated, but it doesn't need to be, it turns out. This is the AMP approved crimp, which I think passed the current test with flying colours. The wire burned all its insulation off, and the crimp hasn't actually yet. It looks a bit discoloured, but it doesn't look too bad. Will you focus? Yeah, doesn't look too bad. Not a sophisticated test. This is a how many white knuckles test. I can't pull this with 2 fingers. Sounds a bit dodgy, that. So I'm going to wrap my fist around it. Okay, here we go, and I am really leaning into that until in fact the ring tag came out the vise. Let's try again. I'm going to try again with the vise tight, and I am really giving this some stick now. Oh yeah, and it went with all my weight behind it. And if you focus, thank you. I'll bring you in a minute. I think we broke the wire. We did not pull the crimp. Yep, so when I finally got my camera to focus, I think you can see there we broke the wire. This crimp has survived every test. Vibration, fatigue, current and tension. It exceeds the rating of the wire in every respect. We can't fault it. Alright, good news. Okay, so next one is the Farmyard crimp. I'm going to say that quite a lot of the heat here came from within the crimp itself, because the wire is much more discoloured. In fact, I would say the wire is more oxidised and discoloured down here where it actually joins the conductive part of the crimp. I'm going to call this a failure of the crimp. I don't think it's completely exceeded the wire rating in the way the others have. Let's give it the pull test. I'm going to start with 2 white fingers. The other end came out. The not so hot end. I think we can safely say that lost its mechanical properties, if it really had any, whilst being heated. I'm going to call that a failure. I think that crimp burned out around about the same time as the wire. Certainly didn't exceed the properties of the wire. Alright, because this is a push-on type connector, obviously it's going to pull apart really easily. Or is it? I think it might have welded itself together. Let's get the old screwdriver. Alright, 2 fingers. Interestingly, I think some of the heat there was generated inside the terminal itself. It got pretty hot down this side. I suspect it's because of the small surface area to conduct the current that the push-on connection itself fails. Okay. Just going to try and pull this crimp out, see how good that is. Okay, I'm pulling quite hard on that. That's pulled the conductors out. So again, that was a cheapie, and that's failed mechanically. So let's try this end. That pulled, didn't break the wire. Now there's one more type to try. Right, instead of that spade type which pulls apart, if we want to have a disconnect in an aircraft wiring loom, we should really be using something like this. A knife disconnect, sometimes called a handshake. And this should, because of the way it locks together, form a disconnectable splice, crimp splice, with the same tensile strength and current carrying properties as the original wire. Now, I haven't heated this one. I know they carried a current, but I am going to do the pull test on it. As I say, this is what we should be using instead of a spade connector. Right, I haven't heated this one. I'm just interested in the mechanical properties of an unheated, correctly crimped PIDG crimp compared to the wire. So already I am pulling like crazy on that. I've got my weight properly behind that. God, I can feel the wire stretching. Do you know what? We stretched the wire a lot inside the insulation, but I think the wire pulled out the crimp. Focus, you. No, it didn't. It's still in there. Alright, we broke the wire. So, interesting. Okay, so what did we learn? I think it's fair to say that these two correctly made, approved crimps did everything we could have asked of them. and I think it's fair to say that they met or exceeded the rating and specification of the wire that we connected together with them. Alright, this one survived extreme overcurrent to the point where the wire insulation melted off, the wire got red hot, and it even retained its mechanical properties, and the wire broke. It survived the fatigue test faultless. Right, can't argue with that. This type of disconnect would give in an aircraft wiring loom a point where you can easily disconnect a component and maintain the original properties of the wire pretty much, as long as you staggered these a little bit in the loom. You would have no issues whatsoever with them. Okay, not a problem. The Farmyard crimp was just to prove a point, really, that if you don't do these things properly, you will not get a mechanically sound, conductive crimp that's going to do everything you need. You put that in a bundle of wires in an aircraft wiring loom, likewise the spade connector, apart from the fact they look pig ugly and take up too much space and rub on other things, they are not going to perform in the same way in service, in long service, and in harsh environments. When a bit of corrosion gets into these, they are famous for becoming high resistance and giving you aggravation. Really don't want them in critical applications. Okay, this one failed. The wires pulled out, even though it was crimped with the tool that was supposed to be used on that crimp. Didn't really work. It's not a proper crimp. Right. So if I had to stake possibly my life and my reputation on wire splices and crimps, these approved types here using the proper calibrated tool is what I'm going to use. And the Sparkies who've had a go at us over the years because they've got thousands of pounds worth of tools and crimps in their boxes, and they say everything should be done exactly in accordance with, are absolutely correct. This is the kind of thing you need in aircraft wiring looms, where you can't just, stop mid-flight and throw a fire extinguisher at a loom, because you will have a problem with one of these types if your cockpit is full of smoke and everything is getting unpleasant. Thanks for watching. Good night.